Today my topic is design of the riser. First I am telling you, so what is the riser? So it is a feeder or reservoir of the molten metal. It is used for a casting process. Type of the riser, blind riser, top riser. So what is the difference between the blind riser and top riser? Let you can see this figure. This is a blind riser or this is a top riser. Number one is it is very easy to remove it. It cannot be easy remove it. Number one. Number two is the blind riser contain the more temperature for a long time so that the blind riser give a better directional solidification compared to the top riser. The blind riser is covered with a sand particle. The sand particle contains some moisture. Due to the moisture, the temperature of the blind riser will be decreased. The blind riser is covered with a PVC sheet to maintain the internal temperature so that the blind riser give a better directional solidification compared to the open riser. Second number is function of the riser. So the function of the riser is to escape the internal gases. The internal gases produced by the molten metal into the mold cavity. Number one. Number two is to compensate the metal. So when the metal is going to solidification, so the size of the component will be the decrease. So how to maintain the size? The mold cavity is receive some material from the riser to compensate the material. Number three is due to the decreasing the dimension of the component, some shrinkage is also produced on the surface of this component. So the riser play a very important role to control the shrinkage on the surface of the components. These are the function of the riser. The material of the riser. The riser is made of the composition of the carbon 32% aluminum 22% are papers. These are the material used for making the riser. The height of the riser is taken in this form: h is equal to 1.5d, h is equal to 1.2d, h is equal to 2d, h is equal to d. The riser will withstand the temperature 14 degrees Celsius to 1400 degrees Celsius to 1450 degrees Celsius temperature withstand the riser. So riser. The requirement of the riser are generally depends upon the what's your requirement and the shape and size of the components. The riser. The line. So you can say this figure. So why not meet this line? You can at the 90 degree. So what will be the effect 90 degree at this point? So when the material is flow when the molten metal is poured into a sprue with a high velocity. Due to the high velocity, the surface area is distorted. So the turbulence flow is create the turbulence flow at this point. So this avoided the turbulence flow. The radius is provided not a 90 degree. So due to the turbulence, they prevent to remove the turbulence flow. So the radius is provided at this point like this. This figure is like this. The what type of the riser are used? So two type of the riser are used. Spherical riser are used and cylindrical. So what will be the better for use the spherical or cylindrical? When the metal is going to this solidification, the area more solidify compared to the S. So there will be the more chance to blockade the passage in a case of the spherical riser. In this case, cylindrical riser, the metal is solidified uniformly at every point. There will be no chance to blockage this passage. So this cylindrical riser always used. Cylindrical riser always used. The, the top riser is further classified side riser and open riser. So this is the, you can see this figure, this is a side riser, this is a open riser. So in this case, the height of the riser equal to the diameter of the riser. In the case of the open riser, the height of the riser is equal to half diameter of this riser. So the volume of the riser, volume of the side riser, pi d square upon 4, the surface area of the side riser 2 pi square upon 4 h plus pi d h. This is a circular portion. This is also circular portion. The heat is transferred on the outer surface of this riser, so it is a cylindrical shape, so the surface area pi d h. Same thing is here. This is a, in case of 2. In case of 2, the volume of the riser is open riser pi d square and surface area open riser pi d square upon 4 plus 2dh. 2dh. From this equation number 1, the volume of the side riser is equal to pi d square upon 4h. So you can find out the h, 4 pi volume of side riser divided by pi d square. Same thing is here from the equation number 3. The h is equal to 4 pi volume of the open riser divided by the pi d square. The value of h, put the equation number 2. Then you calculate the h is equal to d. So h is equal to d, you can calculate the with difference to differentiate with respect to the x. Then you can calculate the h is equal to d. Same thing, the h is equal to d by 2. So from the equation number 4, equation number 4. The designing of the side riser are generally depends upon the three methods: Keynes method, Cronquist method, and modulus method. First, the Cannon methods. Here you can see this, use this table. This is a Cannon method. The freezing ratio is equal to surface area of casting divided by upon volume of casting divided by surface area of riser oblique volume of riser. This is a freezing ratio. So where are you freezing ratio? Where are you? Find out the freezing ratio. So you can draw this type of the temperature along the y-axis, and this is the time along the x-axis. You can draw the cooling or solidification curve. When the molten metal is poured into the sprue like this, pouring metal, and when the molten metal is poured into the sprue, the metal is raised in a mold cavity through the gate. This is a 1 point, this is 2 point. 1 point is here, 2 point is here. This solidification will be the start up to the third point. Up to the third point and suddenly down. This is the solidification, completely solidification of this material. So at the 2 point, the solidification will be the start and end is here at the point the 3. The distance between 2 points is called the freezing ratio. From this point A to 3, this is the total solidification time. Total solidification time. You can draw this figure, cooling solidification, from this figure. This is the cooling time. So the convenient method is use the x is equal to A upon y minus B plus C. You can see this table. The value of A and B and C having a different type of the material, steel 0.1 A, aluminium 0.1 A, value of A in cast iron 0.03, the value of B steel 0.03. So you can see this type of the table. The M is the freezing constant. M is freezing constant. Y is equal to construction ratio, liquid and solid. This is a liquid and solid. This is the value of B. C is the constant for different material. These different material. And also you can draw this. Can be a hyperbolic curve. You can draw a hyperbolic curve. This is the riser volume upon casting volume along the y-axis and freezing ratio along the x-axis, to draw this type of the curve. If you want to cast this type of the workpiece, then how to draw this curve? So what is the meaning of this curve? So your curve will be like this. To match this curve with this, tally this curve. So your curve is here above this line. So your casting is casting is very good. So your curve is down from this line, so that your casting will be get a shrinkage, more shrinkage. This curve is called the Kelvin hyperbolic curve. Second number is carbonium rule. The carbonium rule is here. So you can see this. This is by the carbonium rule. The time of solid of the riser, the solidification time of the riser is greater than the solidification time of the casting. So how to prove it? The solidification time of the riser is greater than solidification time of the casting. How to prove it? So when the material is solidified, the metal is first solidified, the cavity cannot be received. The casting cavity cannot be received from the material, because the material will be the first casted, solidified. So the solidification time of the riser is always greater than the solidification time of the casting. The solidification of the casting, this is the total solidification time. So this is the total solidification time from this 1 or 3. Total solidification time directly proportional to the volume of the casting and surface area of the casting, power n. So power n is this is the K, n is exponent. The total solidification time TST, or riser, C casting, n is the exponent, then n value of 2 is used. So this is the Carbonius rule. Third number is modulus method. What is the meaning of modulus? What is the meaning of modulus? Modulus means this is a casting. So modulus means it is a point where the casting is solidified, that at this point. Solidified, the point is where the casting is solidified, that is called the modulus. The modulus having a different shape and size, have a different type of the modulus. Like this, you can say it, this is a flat, the m is equal to 0.50, this is the modulus of the flat, a long bar A into B divided by the 2 A plus B, the modulus. These are the figures have a different type of the modulus. The modulus affecting the riser having the MEF value. MEF, modulus affecting factor. The modulus of effective factor means the factor of factory. The modulus of affecting factor always used for a casting 1.25 and sand 1. So modulus affecting factor for the sand, you will take the 1, or modulus affecting of the factor for the other material 1.35. The shrinkage, how much shrinkage is allowed on the components? The percentage of shrinkage vary from 1.7 to 2.7%. So 7%. These are the figures. Different type of the numericals can be solved by use of different type of the formula. Designing of the riser. Riser is play a very important role in casting the different type of the components. These I think you will like my lecture. Thank you very much.